A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I welcome you all in today's our online session. Hope you all are fine and having good health. We start our today's session for applied physics course. So we start today's session with some words of Holy Quran. After that, in previous session, we was discussed the electronics component, which are the five basic and major electronics component and application of electronics in the field of physics. So this is the main topic which we are discussing in now these days in applied physics. So resistor is a particular component or device which is oppose the electric current. So it's a review of previous session in some of the 1 minute, and after that I further start today's session of topic the usage of these five basic components of resistor, capacitor, inductor, diode, and transistors in the further application and drive application of electronics related with the applied physics. So this is how resistor looks like. It's a component of electronic component, and we name it a resistor. Definition I already discussed. So this is the inner diagram of resistor. This is the symbolic representation of resistor. Afterwards, this one is the color coding of resistors, type of resistor, precision, how can we get it from resistors, film type, resistors, variable resistor, which is another name we called a potentiometer. So how we calculate a resistor, we also discussed in our previous session in the combination of series and parallel as well. Uh, uh, After that, the practical use of resistance and how if we need to increase the resistance with what will be the notation, and if we need to reduce the resistance, what will be the notation. To reduce the reduction of resistance after the combination, which is the parallel combination, and to increase the resistance, we need to connect it in series combination. Afterwards, the second category of component was capacitor, is an electronic device as well, or electric device which store electric charge in it. So notation of capacitor also we connect in series and parallel as well, but opposite as compared to the resistor. So variable capacitor, that how it looks like, and furthermore the combination of these resistance we discuss in our next slide as well. So low capacitance, high capacitance, how we can get the capacitance on which the capacity depends, or the capacitor, we also discuss these factors as well. Afterwards, these are the capacitor combination in which if capacitors are connected in parallel, then how it looks like, and the capacitors are connected in series and how it will be looks like. After that, how is the scheme by which the capacitor store electric charge in it, and open switch and close switch, this concept we discussed in the slide in previous session as well. Afterwards, if as a resemblance like a resistor, we can say the variable resistance concept is also be available in the variable capacitance. Like the variation in capacitance, we can also be get by the variable capacitors. So like a potentiometer. So practical use of or the application of these capacitors or electronics are also we discussed by these combinations. And there is a vast variety of application of resistor, inductor, and capacitor in the field of electronics and electric of cars, appliances, devices. So etc. kind of things can be discuss in later slides. So the third component which we need to discuss, like we called it inductor. So inductor is also a device to store energy in the magnetic field, like electromagnet. So it works on the principle of changing current of changing magnetic field, and with the uh, energy like a energy storage device. So it work on the principle of changing current with the changing magnetic field of flux. So how we can need to find, and how we can find the combination of parallel and series inductors is, so by these combination in series and in parallel as well, like a resistor. So its inductor combination are similar to the resistors, but opposite to the capacitor. Inductance is determined by the four factors, which we also discussed in our previous session as well, like uh, how these four factors are discussed. So number of turns, if the number of turns increase, then the inductance would be increase, and opposite is vice versa. Permeability, the type of core by which it make. So hard steel have lower inductance, and soft iron have the high inductance. So permeability, permeability is the quality of material by which it make. Cross sectional area of core, that if we make a thick core of inductor, then the inductance will be low. And if the cross-sectional area of inductor is high, then the inductance value we get in high as well. Spacing of number of turns, if we increase the spacing in between number of turns, then the inductance would be low. And if the spacing in between the number of turns be high, then the inductance we find in the high value. So these are the four factors by which we can uh, high and low by our will, by the combination of these different aspects. So variable inductance we can also be found by this way. Inductors store energy in magnetic field. We discuss these two concepts, that the current is flow from the conductor, and the magnetic field would be looks like this. And if we transform the conductor into number of turns, then the magnetic field will be look like in this form. So this is the formation of inductor, and the magnetic field would be penetrate the inductor by which it wire wound. So types of inductors: air core, adjustable, iron core, tap type of inductors we also discussed. So the fourth category of electronics is as per the combination, as per the device, as per the component, which is the diode. So diode, it's electronic device as well, which can transform and convert the type of current like AC into DC. So this one is the symbolic representation, and a pictorial representation and physical aspects of diode. It looks like in this form. This layer is the anode, and this layer is we called cathode. So the types of LED, the types of diodes are LEDs, light emitting diode. This is the type of diode by which it emits the light if the its substrate of anode to cathode electrons flow, then it will originate or glow the light from its substrate. So LED, we all know about LEDs. So the next application of or the type of diodes are the photodiodes. So photodiode are the type of diode on which the light strike on the metal surface of anode, then the charge of electrons are flow from anode to cathode. So this is the concept of photodiode. So practical use of diode, that why we need to use diode in different kind of application, which are the making of gates, use of making rectifiers. Rectifiers are the converters which can transform your direction current from AC to DC. used as a switch. Diode can also be used as a switch. Diode can also be used as LED indicators in many applications of electronic cards as well, electronic devices as well. Even our phone charger, mobile chargers. So are the applications of diode like LED. Photodiodes as a light detectors. So it works on the presence of light. So this is the practical use and application of diode, which is the fourth category. The fifth category of electronics device is the transistor. So it's all about the review of till now. So the fifth category of component which we used in application of electronics like physics is the transistor. So it's a semiconductor device which commonly used in application and switching uh, purpose in electronic signals and electronic devices as well. So transistor consists of three leg of terminals, emitter, base, and collector. So there are two types of mainly bipolar junction transistor, which are divided into two types, NPN and PNP. So NPN is work on the straight switch, PNP work on the inverted switch applications. So you can see the difference in between these two things as well. Now further, the NPN as straight switch. So NPN can be work on the principle if the base is uh, energized, then collector to emitter can be charge can be flow from collector to emitter, then it work like switch on state. And when the base is connected with the low logic of P substrate, so it's a three terminal layer of device which is the NPN, and this one is PNP. If you're talking about the NPN, then if base is energized, then collector to emitter charges can be flow. And if you're talking about the PNP, the inverting switch, if the base logic is low, then the emitter to collector charge can be fulfilled. So, but the natural direction was collector to emitter was it will be flow. Then we can say this is the inverting logic. If the base is low, then collector to emitter would be high. And if the base is high, then collector to emitter charges are not flow. So and PNP is work on the inverting limited applications, but NPN work straight switch in most of the applications. So it have the vast variety of scope and it have the lowest variety of scope in applications of electronics. Further, so this concept I already discussed and I explained you guys in from this pictorial representation of NPN and PNP, how it works on the straight switch, how it works on the inverting switch. So the concept which is reflect by this slide is the NPN and the straight switch application. Now further in this PNP as inverted switch, we already discussed that if the N is high, then it will be switch off. And if the N is low, so it will be on. So it work on the inverting switch application. So that is the reason it act and it work like the inverting application. So it have the limited scope. So further applications and the uses of transistor in electronics are it work as a switch, as an amplifier for realized logic gates applications as well. Now, this is our today's uh, topic of power. Now, power, how these five major components, resistor, capacitor, inductor, diode, and transistor. So these are the five major component used in electronics. So further, the terminologies are derived by their combination, their uses in electronic circuit as well. Further combination or the topic, we need to discuss the power. Power is the rate of energy consumption. The rate of energy is called consumption is called power, And as well, the second definition, which is not mentioned here, is uh, the rate at which P is equal to E upon T. The rate at which uh, the rate by which the energy would be changed, then we call it a power. The rate of doing work is also a power. So that's the reason it's having the formula P is equal to E upon T. The basic unit of power is watt. Power can be calculated as follows, like P is equal to I into E. Since E equal to I into R, this is the second category. This is same scenario, that E is equal to I into R. The rearranging the equation, the rearranging the value of in terms of Ohm's law. This is the Ohm's law, V is equal to IR, sorry. So we can also be use the value of E in this equation, then it would be transformed to P is equal to I square into R. And if we arrange the Ohm's law in terms of current, this is the arrangement of Ohm's law in terms of voltage. So the arrangement of Ohm's law in terms of current, it would be transformed I is equal to E upon R, or V upon R, we can say. So use these value I is equal to E upon R, it will be transformed to P is equal to E square upon R. So these are the three main formula which is used in many electrical and electronics application, and to calculate the value of power. If we given voltage and current, then power can be found. And if we have R and I, then power can be found. And if we have voltage and resistance instead of all these things, so then power could be found by this third formula. So these are the reciprocating formula, drive formula of power by these scenarios. Now the basic and main two terminologies of measuring the current and the measuring the voltage by the meter, we need to discuss in this slide. So ammeter must be a part of circuit to measure the current or electronic current. So if we need to find the electronic current, so we need to connect the ammeter. It would be, can also be said, it is the voltmeter, volt and volt and ohm meter. So if we need to, it having the formula as well, the avometer, avo, ampere, volt and ohm. So these are the some of names of its meter. So now these days we are called it this meter digital multimeter normally. So the selector switch can also be out there, and we can select by our will the particular meter, and the parameters would can also be drive or change. So this is the needle deflection tells us that it's analog meter, but in digital meters it tells us the reading in digits. So further, so worm multimeter that measure voltage, current, and resistance. So these are the another way of name of that worm meter. I called it at avometer, multimeter. So these are its name. So if we need to measure the voltage of the circuit, so we need to connect the light bulbs in series. If not exactly we need to, it is not mandatory to connect these load of bulb in series, but another way of combination can be arranged by other ways. So if we need to found measuring the voltage from electronic circuit, then we need to connect a particular meter in parallel by the load. If we need to connect, or we connect the meter in series, sorry, in parallel, then particular load between two these meters of light lamp volt can be appear on the screen. Like a 12-volt battery provide 12 volt to these three lamps of bulb, And if we need to find a particular one bulb of voltage, that how much voltage is dropped on this bulb of lamp, then we can be found by connecting these two terminal of leads towards the bulb of light. Then voltage can be found by this needle deflection value. And if we need to find that how much voltage is dropped in these two bulbs at a time, then we need to connect one probe of meter in this place and another probe of meter in this place. Then both the voltage of meter which is dropped in these two lamps can be appear on the screen of ohm meter. So this is the way that how to find the uh, voltage of measuring voltage by the meters. So further, this is another way to measure the current. If we need to measure the current of a same circuit, you can see that this symmetry is now open, and in between these two probes are connect here, that how much current is drawn by this series lamp of circuit of bulb, then the particular current can be appear on needle deflection of ohm meter screen. So we need to first select that particular ampere, which is the selector switch, by the selector switch, and the series, in series notation we can connect the meter in series as well. So we even we also know that in series circuit, this is the series circuit, the current is same in whole scenario of a circuit, but if it connect in parallel, then the symmetry would be changed. So we are not complicating the situation. So we assume that same scenario to measure the voltage and measure the current. The difference between that, if we need to measure the voltage, we need to connect that particular meter with particular load in parallel. Then the voltage would be found on the ohm meter screen. And if we need to measure the current in series, so we need to connect the meter, this symmetry of series, to open the circuit and connect the meter in series in between battery and the last of bulb. Then the current would be a pair of that whole circuit on the screen of ohm meter. It is not mandatory to connect that meter in the last. You can also be connect this meter in by the replacing of this wire, and to connect this wire directly to this one. So same value of current can also be appear on that screen of needle deflection ohm meter, analog meter. So this is the way that how we can measure the value of current by analog ohm meter needle base meter. So this is all about today's lecture. And today mainly we review the whole scenario of electronics component, resistor, capacitor, inductor, diode, transistor. After that, we discussed the uh, concept of power and how we can found the power by the three ways: by the manipulation of Ohm's law value in terms of voltage and current. The alternation of voltage current can be reflected by the three formula of power: P is equal to V into I, P is equal to I square R, and P is equal to V square upon R. These are the three combinations by which we can find the power of the circuit. And if we need to find the value of current by a circuit, we need to open it first and connect the a probe of meter in between the circuit, then the current would be found. And if we need to find the voltage of the particular circuit, we need to connect this meter towards this bulb, then the voltage would be appear on the analog ohm meter screen. This is the way that how to measure the voltage. So this is all about today's lecture. If you have any kind of question, query, difficulty regarding today's session, please feel free to discuss. I will answer the kind of question and resolve your queries if you have in your mind. Otherwise, we end today's session. Thank you very much.